All right, so in this lesson, we will talk about collection data structures in Java. So data structures are collections of organized data. They store the data and they provide methods, operations that manipulate the data, right? Sometimes you'll also hear the term container object to refer to data structures, right? In Java, data structures are defined by a class, an example being ArrayList that we are used to from recent lessons that provides a data structure to store elements in a list. Java actually provides several data structures that are grouped together and are known as the Java collections framework, right? And these are for representing things like lists and vectors and stacks and queues, priority queues, and sets and maps. These can be grouped into basically two categories. They're collections that store collections of elements, groups of elements, and maps. These store a bunch of key value pairs, and these are really useful for fast searches based on a key where you want to get to the value part of it. And we'll actually talk about maps in a later lesson, right? So let's talk about collections, right? So collections include things like sets, which are groups of non-duplicate elements. They cannot have duplicates. Lists, these are ordered collections of elements and can contain duplicates, but there's an ordering here. Stack, like the name sounds, is a collection of elements that operate in a last in, first out fashion. So stack of books, the last book put on is the first book that comes off the stack. A queue similarly has first in, first out semantics. So the first person in a queue is the first person who gets out of the queue. Priority queues add the notion of priorities for processing elements, and we will talk about that again in a later lesson, right? So the common thing about collections is that they're defined by interfaces and they're implemented with concrete classes. So actually, for that, let's look at the UML diagram for collections, right? So this is the bigger UML diagram for the collections that we will talk about in this lesson. So one pattern you'll see is that the framework for the collections is defined by a set of interfaces, right? And that's why the names are in italics. They are partially implemented by a set of abstract classes, right? Again, the name in italics, and then they're fully implemented in concrete classes, right? So that's where you have the full implementation, and now you can go use them, right? So now the root interface is called collection, and it provides specification for certain methods, certain common methods that all of them end up implementing, right? So let's go through that very briefly. Here are the important ones that we will talk about. There is add, which adds, given an element, it adds it to the collection, right? Add all is given a collection and adds all the elements from the given collection to the source collection. Clear removes all elements from the collection, empties it out. Contains checks if the collection contains an element. Contains all checks if given another collection, if all the elements on the given collection exist in the source collection, right? Equal checks if one collection is equal to another collection. Hash code returns a numerical hash value for the collection. And this becomes important in subsequent lessons. I just want to introduce it here. Empty checks if the collection is empty. Removes an element from a collection. Remove all is given another collection. It removes all the elements in the given collection from the source collection. Retain all retains all members in a given collection that exists both in the given collection and another collection. So these now start sounding a lot like set operations, which we'll talk about in a bit. Now size, it returns the number of elements in a collection. two arrays will basically gives an array version of the collection. And sometimes that's useful, to process in certain situations, right? Now, some of these methods, add all, remove all, retain all, return a value, which is a Boolean. And this Boolean tells us if the collection has been changed because of this operation. So as an example, suppose we're removing an element. If the element doesn't exist in the collection, then the collection hasn't changed and remove will return false. But if it does contain that element, then the collection would have been changed and remove will return true. So that gives an indication whether the collection has changed. Now methods add all, remove all, and retain all are basically same as a set union for add all. Remove all is the same as set difference, and retain all is the same as set intersection, respectively, right? Okay, so note I had mentioned that you start with interfaces, then you implement them with partially with an abstract class, and then you give full implementation. So here collection is the interface. Abstract collection implements part of the class, but not others, such as add. And then ArrayList gives us the full implementation. Now can be used. So that's an example of the three different type of interfaces and classes that come into play. Okay. So now let's write some code and let's try some of this out. So this is an example where I've tried to use kind of most of the methods I've talked about as much as possible. So in this program, we have a couple of array lists, C1 and C2. I build C1 by using add a couple of times to add 4 city names, right? And then if I print it, you will notice it is printed in the order the cities were added. Then I called remove a couple of times. First I call it with a city that doesn't exist in C1, and notice it returns false because the source collection didn't get changed. Here I call it Toronto, and it does find it, does remove it. So now if I were to check how many elements are there printed, I will only see 3 elements. Now in C2, I build it up with 4 cities, Delhi being the common one between both of them. I check size of C2, and that's 4. If I print it out, I'll see it printed in the order that I added the cities. Now I create a third array list by cloning C1. Notice I had removed Toronto from C1, so it would have only 3 elements in it. And then I do an add all with C2. So the 3 elements here and the 4 elements here now are all put together, are union into C3. And if I check the size of C3, I'll get 7. And if I print it, I will see them printed. Okay, and then I do a difference between C1 and C2, an intersection, a retain all, right? So the only thing common between C1 and C2 is Delhi, so I will get Delhi here. And then I go back to C2, which had 4 cities in it, and then I do a remove all from C1, and Delhi will get removed and only 3 will be left, and that's what is shown. So feel free to copy this and try this out, and we will do the same. It will work pretty much as expected. Let's kick off IntelliJ. We'll print this here and run it. And we will see things pretty much in the order that we kind of expected it. We had the remove from the false and true from the remove, and the sizes and such, as it showed up in the code, right? So feel free to play around with this as well. Okay, getting back to the lesson. So the collection interface itself extends another interface called iterable, right? Now the interval interface is very interesting. It defines a method called iterator, right, which returns an object called iterator, right? So iterator, the object, provides a technique for walking through the elements of a collection in kind of a uniform way, regardless of what type of collection it might be. Iterator object provides sequential access to the elements using a method called next, and there's also a has next method to check if you have more elements left to go through. You know, this will look familiar to you if you use the scanner object, right? So for this, let's actually use it with a piece of code. So here you have a very small example where I have an array list and have added 4 city names to it, right? And I want to go through and print each of the city names in order. So you will notice I have used the iterator method from the collection, which was provided because it implements iterable, right? So iterator itself is a generic, you will notice, and I'm using the has next method of the iterator, check if there are more elements. If there are, then I use next to get the element that where my cursor happens to be, and I print a new line at the end. So let's actually try this out. It's a very small example. We will kind of overwrite what we had earlier, right? And it's a very simple example to kind of take a look at. Okay, so let's run this and see what it prints. And it basically prints things in order. There's a space in the middle because of the space I've added, and there's a new line at the end because of this new line. Right, now there's a short form for this, which is called the for each version of this loop. Now, the keyword here still is for, even though it's called for each, it's still a for. And it kind of provides you this kind of notation where you have a type here, and you have kind of a placeholder variable that you can use to go through it. So you don't have to use iterator, has next, and next. It's kind of very intuitive and kind of gives the same effect if you try that out. So let's go back and put that in. And we'll actually put that in at the end so we have both to show that this is basically equivalent, right? So if I run this, I'll just get 2 copies of it. They're both doing the same thing. Okay. So now we've talked about a specific example with ArrayList. Now let's back up a little bit and talk about lists in general, right? So there are actually 2 versions of lists that are provided. There is ArrayList and LinkedList. Now, list is a collection of elements that are stored in sequential order. We've seen that the order you add things in is the order that it'll print it out, right? And also duplicates are allowed in lists, but they're just the ordering of the elements, right? So the methods that are, and let's actually go find ArrayList and LinkedList in our UML diagram. That would be kind of interesting. So you've got ArrayList here, you've got LinkedList right here, right? Okay, let's go back. And so what method does list provide? You have your add and add all and remove, and you have the ability to set an element at a particular index of the list. You can give an element and say, hey, what is the index of, where does this appear first? So this index of gives you the first occurrence of that element, the index of the first occurrence. Similarly, there is a last index of that gives the last occurrence of that element. And you can get a sublist with from an index to an index -1, get a sublist, right? So let's work with ArrayList a bit to try out some of these things, right? So similarly, I have a piece of code, and let's just kind of go through it and look at it, see what is happening. So here I have a single array list called C1, and I have added cities to it. If you print it, they appear in the order. Then I am adding to an index. So you will notice that before there was just an add operation, but now this is a little different one. This, you're overloading the notion of add, and I'm providing index 2. So it's saying add index 2, put Madrid, right? So what happens here? So this is index 0, this is index 1, and this is index 2. So when you add, it is basically adding it and then moving all of them to one side. It's a little different from what set does, and so we'll get to set in a little bit. Let's see. Then I go ahead and I'm creating a second array list. I'm adding a couple of cities there, right? So it will have Dallas and Houston. And then I'm taking everything in C2 and I'm adding it to C1. So now it has grown. It has the Dallas and Houston have gotten added to in a particular location. They've gotten at index 2. So it went to this position, then this position, and this is index 2, and put Dallas and Houston right there in the middle and move everything to one side, right? Then I go ahead and remove something, Moscow, which got removed, so it becomes a little smaller. Then I'm using set. Now this will show you how set is different from add. Set basically overwrites that location. So it's saying put Delhi at position 6. So 0, 1, 2, 3, 4, 5, and 6. So it overwrites Paris with Delhi. Okay. Then I try index of. What is the first occurrence of Delhi? And should return 1, 0, 1. What's the last occurrence of Delhi? It gives us 6 because we just overrode that location. Then I said, hey, give me a sub list of this, starting at position 2, going up to position 6 minus 1, which is 5. So 2 to 5. So we have 0, 1, 2, right? And 3, 4, 5. So it'll give us Dallas, Houston, Madrid, and Toronto, which is what it gives. Very quickly, let's just do the same thing and try this out. Nothing surprising. It's a good thing to play around with just to test your understanding of how these things work. So we will go ahead and overwrite everything here, right? And we'll run it. You guys can play with this. It's going to give you exactly what's expected in the comments, right? So do try it out. It is fun. Okay. Now, ArrayList does have a method called ListIterator, or ListIterator with providing an index that returns something called a ListIterator object, right? Which is very similar to the iterator object that we spoke about earlier, except that this provides bidirectional access traversal to the list. You have next, but you also have previous, and you have has next, you also have has previous. So it gives more finer grained control over the iterator. We have an example a little bit later. So this is all I'll say about it here. Okay. Now let's talk about the difference between an array list and a linked list, right? So an array list, as the name suggests, stores the elements underneath in an array, right? And as the array becomes full, it allocates a larger array, copies all the elements into that array, right? A linked list stores the elements in an actual linked list. It allocates only the amount of memory that it needs and keeps stacking things on to the list as needed, right? The question is, okay, which one do you use, right? So it depends on the use case. Now, if you need random access, you're indexing, you have a big array, a big list, and you want to get to the 56th element, then an array list is good. especially if you don't want to do insertion and deletion from the middle, right? An ArrayList is perfect for that. If you do want to do insertion and deletion in the middle and you want the control the size, then a linked list is better, right? ArrayList, however, does provide something called trim to size, which does trim the array to exactly what you need. So it does provide that functionality, right? So linked list supports adding and removing elements from the beginning of the list and end of the list additionally. Add first, get first, remove first, add last, and so on. There's also a getI method available for linked list to get to a particular thing in the middle, but it can be very time consuming, because unlike an array where you can index very quickly, a linked list, you have to walk through the list to get to that particular thing, right? So depending on your use case, use one or the other. So let's actually write some code to try these things out, right? So first we'll start with an array list here, call A1, add a bunch of numbers to it, and we will also stick something in the middle, 100 here, and then we'll print it out, right? Now we create a linked list of type object, so you can use it to store lots of different type of things. And we provide as part of a copy constructor, if you remember that term. So it initializes the linked list to whatever was in the array list earlier, right? And then we add red to the middle of the so now it's contained some numbers and some strings, right? And then we do remove last to get rid of the 5. Then we add first to put something in the beginning. And now we're using a list iterator show bidirectional access. So in the first while loop, we're going through it forward, and in the next one, we're going through it backwards, right? So this one, it prints from blue to 4, and then the next one prints 4 to blue, right? Quickly, we'll run this. Nothing magical about it. Open up IntelliJ, right? And overwrite what we had earlier. And let's just run it, right? We'll see what we showed in the comments of exactly how it's built and the iterator being used. Feel free to play with that. All right. So this has been a lesson on data structures, which are called collection data structures, right? Provided by the Java Collection Framework. Thank you.